I'm going to go ahead and find all the solutions of secant squared of x minus 2 tangent of x equals 4. And as you can see by the title of what we're going to be doing right now, we're going to be using our inverse functions. And sometimes that's necessary because, well, you're not going to be able to find a value of x. So that's when we're going to have to use our arctangent or arcsine. And you'll see that right now. So let's see here. First of all, we have to use what we've already learned, and that is that if we're going to find any solution, we want to write our equation in terms of only one trig function. And since secant squared is one of our nice Pythagorean identities, I'm going to go ahead and replace secant squared of x with 1 plus tangent squared. All right? So let's go ahead and start by doing that. So 1 plus tangent squared of x. So I just replaced secant squared with 1 plus tangent squared minus 2 tangent x equals 4. I'm just going to go ahead and move the 4 over here and kind of write this in descending order, starting with the highest exponent. So tangent squared of x minus 2 tangent of x. And then if I subtract 4 over here, it's going to give me a minus 3 equals 0. All right, well, as you can see here, this is now a quadratic in quadratic form. So we can factor this. And I'm just going to leave it in the form that it is. Remember, if it helps you, you can rewrite this as x squared minus 2x minus 3 equals 0. Factor this, and then replace tangent with x. So I'm just going to go and just factor it in this form right here. So I know that my first two terms must give me tangent squared. So tangent of x, tangent of x. And I know that these two terms must give me 3. So 1 and 3. Let's see, in the middle, I need a negative 2 tangent x. So tangent times 3 will give me a negative 3 tangent. And then tangent times 1 will give me a positive. So negative 3 plus 1 will give me my negative 2 right there. Okay, so let's set each of these factors equal to 0. So tangent of x plus 1 equals 0. And I have tangent of x minus 3 equals 0. All right. Let's go ahead and isolate the trig function. So now this means the tangent of x equals negative 1 and the tangent of x equals 3. All right, so let's just deal with this one real quick. This one, we know how to do this one. Tangent of what is negative 1? And we want to stay within our, let's see, we want to stay within, because we're going to be using the inverse trig function. Let's remember, if I want to find the tangent of something equals negative 1, we have to be within negative pi over 2 and pi over 2. Okay, so the tangent of what is negative 1? Well, that's going to give us negative pi over 4. Okay, so that's how we get that guy right there. Now over here, if you're not going to find anything on the unit circle where you do the tangent of something that equals 3. So this is when we have to actually use our inverse trig function now. So what I'm going to do is that I'm going to take the cotangent, I'm sorry, not cotangent, I'm going to take the inverse of tangent of both sides, which is the same thing as saying arctangent. Okay, and this is what I mean by that. Like, I'm going to do the arctangents of tangent of x. But then whatever you do to one side, I have to do the same thing to the other side then. So that means I'm going to take the arctangents of 3. So let's remember, if you take the arctan of tan, those are inverse operations, so those just cancel out. So I get x equals, and it's just this. It's arctangent of 3. And then you can put this in your calculator and and you'll get a decimal answer, but there's nothing that we can simplify here. So this is why we were forced to use our inverse trig function by taking the arctan of both sides. And if you wanted to think about this one, I mean, we could have done the same thing if you want. We could have taken the arctangent of both sides over here. Now watch this. That's just for the sake of legitimacy here. So say if I did arctangent or inverse of tangent, right? Okay, those are the same thing. Of tangent of x equals negative 1 right here, right? So the arctangent and the tangent cross out, and the the inverse of tangent of -1 is pi over 4, you see. So we could have used the same principle that we did over here on the right with the one on the left and still obtain -pi over 4.